So, dear students, last class we dealt with weathering and especially we went in detail about mechanical weathering. So, today we will be dealing with chemical weathering, which is a process of alteration of rocks. The process of alteration of rocks on the crust by chemical decomposition. So as you know, weathering is something or a process where the rocks are broken down into smaller particles, and when this process of alteration of rocks which is present on the crust is carried out by chemical reactions, or when it is a chemical decomposition, it is called chemical weathering, and usually they are carried out by atmospheric gases and moisture. So you have to think how these rocks get weathered, because they are exposed, their surfaces are exposed to the atmosphere, and the atmosphere contains certain gases and it contains moisture. So the gases like carbon dioxide, nitrogen, hydrogen, oxygen, etc. react with moisture or water vapor which is present inside the air to form acids. For example, when carbon dioxide present in the atmosphere reacts with water vapor or moisture, carbonic acid is formed. And don't think that it's very acidic in nature, it's very weak acid. Or because of such reactions, the acid being formed is very weak in nature, but prolonged exposure to such acidic medium will create a kind of chemical reaction on the surfaces of rocks. Another example is nitrogen, because when nitrogen is getting reacted with moisture, a weak nitric acid is formed. So you have to understand that the rocks are made of minerals, and all of them may not be in chemical equilibrium. As I told you in last class, rocks are made of minerals, and the minerals are the building units of rocks. So when these mineral surfaces or the mineral surfaces of the rock are exposed to these chemicals formed in air, that is carbonic acid or nitric acid or any acidic medium or any medium that is formed due to reaction with moisture and air and these gases, they react, or what happens to the minerals or the mineral compositions of the rock which are unstable is that due to these exposures, the unstable chemical or the unstable surfaces of the rock react with these chemicals that are formed to gain back their equilibrium, or rather we say chemical equilibrium is regained through reactions. So in the end product has a different chemical composition and a poorer physical constitution than their parent rock. It is to be noted that the unstable mineral state of the rock is the reason for this kind of weathering? And in the presence of weak acids or formed from air, I mean, from air, the moisture and the water vapor present in the air react with gases to form acidic medium. So we can say that from thin air, the acidic medium is getting formed, and they react with the surfaces of the rocks or minerals which are unstable to make or bring back the balance or chemical equilibrium, and hence we have a kind of weathering known as chemical weathering, where the rocks undergo chemical reaction and the chemical composition gets changed, and their physical constitution and their strength also gets weakened. Now, there are many processes which are involved in chemical weathering. In short, we have to understand that first one is solution, second one is hydration and hydrolysis process, next is oxidation and reduction process, then comes carbonation process, then colloid formation process. And last but not the least, we have a special kind of weathering known as spheroidal weathering. So a kind of processes that are involved in chemical weathering, first one is solution process. Now from the word itself we can understand that it's something related to solution. So think about it, and we have to understand that rocks may contain one or more minerals that are soluble in water to some extent. So when you speak of solution, you have to just think of solvent solution action. And for example, you have on rock, you have rock salt, gypsum, calcite, etc. And you have to understand that all these gets dissolved in certain solvents which are available free of cost in nature due to some reactions or something like that. You have to understand one more thing, that pure water is not a good solvent. Actually, the water which is very pure is not at all a good solvent. And what does make water a good solvent? It is the ionic part or the ionized state of water or a particular solvent becomes a particular liquid is becomes a solvent when there is an ionic disintegrated existence within the solution. For example, when pure water is not a good solvent, and when pure water combines with carbon dioxide, a weak solvent action is enhanced through carbonation. That is, pure water, when it combines with carbon dioxide which is present in the atmosphere, it's called carbonation, and its solvent action is enhanced. For example, if you take the case of limestone, it is not easily soluble in pure water, but carbonated water has a capacity to dissolve limestone. Again, another important reaction, natural reaction or a natural chemical process that is involved in weathering is hydration and hydrolysis. Now, addition of hydrogen can be called as hydration, or hydrolysis is a reaction with water. So, in short, how does these reactions occur? Now, direct attack of water in the form of moisture is always there when rocks are exposed to atmosphere containing moisture or water vapor. In such situations, individual minerals change its structural makeup. That is, I told you, minerals are the building stone of rocks or the building material of rocks. Now, when these minerals are exposed to water vapor or moisture, presence of water molecules, gradually, in certain cases, when the mineral is prone to reaction with water, the reaction occurs, and as a result, there will occur a change in its structure or structural makeup. Regarding the structural makeup, you will learn later in the syllabus, in the later modules. You have to understand that the interior of many minerals are in electric equilibrium, and the minerals are the building materials of stones or rocks, and the mineral as such is a basic unit of rocks, and as such, when you consider a mineral, the interior part of the minerals are always in electric equilibrium. And this is very true in almost all many minerals. But you have to understand that the surfaces are not in electric equilibrium. So surfaces have crystals with partially unsatisfied valencies. When polarized water molecules come in contact with such crystals, it may cause any one of the two reactions which are going to be mentioned. The first one is the ions tend to hold the polarized side of the water molecule and form a hydrate. This process adds a water molecule, and the process is termed as hydration. For example, calcium sulfate, when reacts with water, it becomes gypsum. That is, CaSO4 is in the anhydrate form, but it reacts with water and it forms CaSO4 Now, second type of reaction is that it's a kind of ion exchange. The process of exchange of ions of water is known as hydrolysis. Usually, silicate minerals. Silicate minerals are quite abundant in rocks. Now, these silicate minerals undergo this kind of weathering. It's known as hydrolysis, when water or is present in its ionic form, and when they are exposed to minerals, the mineral surfaces are in unstable form, or they are in the polarized form, and there is an ion exchange. And due to this ion exchange, there is something known as hydrolysis happening, and as such, we have an example as weathering of orthoclase. The difference between the two types are, in the first one, we have a water molecule that is getting fixed. That is hydrate formation. CaSO4 plus 2H2 gives CaSO4 2H2, that is gypsum. That is a hydrate. Now, when these ions react in the second type of reaction, what happens is that we have something known as hydrolysis, where there is an ion exchange. Here fixation of a water molecule is not happening, but what happens is that an ion from water reacts and that ion is getting fixed and not water as a molecule is getting fixed. For example, weathering of orthoclase. Orthoclase is a mineral. Now let us think that the mineral, the orthoclase, it contains potassium. Actually, orthoclase, the main mineral is potassium, and its arrangement makes it orthoclase. Those things you will learn later. Now, this orthoclase is potassium, and it orthoclase plus AlSi3O8 plus H plus, that is what you call ion from water, gives HAlSi3O8 plus K plus, where HAlSi3O8 is silicic acid like structure. So what happens is that when from water, when H plus ion is getting fixed, K plus ion, that is potassium, is released. So due to these reactions, there are chemical changes, structural changes, and hence it's a kind of weathering, or it creates a kind of weathering. Next is a kind of oxidation and reduction reaction that will cause weathering. That is iron, or what is called iron. Here iron is something that is we use as a metal. So it is not ionization that is being that is our concern. So iron is a chief constituent of many minerals and rocks. It is Fe. We know that iron bearing minerals are prone to chemical weathering. Now, the most important reaction that affects iron is, there are two reactions, that is mainly oxidation and reduction. Now, as you know, oxidation is the removal of electron, or it's an increase in positive charge, or it can be said that it's an addition of oxygen, or it can be said that it is a fixation of oxygen. For example, ferrous ion becomes ferric. Fe2 plus becomes Fe3 plus in the presence of moisture or water. That is, ferrous is getting into ferric because ferrous is very unstable and absorbing moisture, it becomes ferric. So when exposed to moisture, ferric ion also being unstable, it is further oxidized into stable ferric hydroxide. So 4Fe plus 3O2 gives 2 Fe2O3, and further Fe2O3 plus H2O makes it Fe2O3 H2O2. Similarly, pyrite, which is a mineral, plus oxygen plus water gives iron sulfate plus sulfuric acid. And again 2Fe2 plus 7O2 plus 2H2 gives FeSO4 plus 2H2SO4. Now this is the same thing given in chemical formula. Next is reduction. Now reduction deals with, or reduction reaction is something, an addition of electron, or it's an increase of positive charge, or it can be termed as a removal of oxygen. Usually oxygen can be removed from a compound or a mineral when it is reacted with carbon or carbonaceous materials. Now here in reduction reaction, an example is ferric becoming ferrous, or ferrous becoming elemental iron. For example, when soil is rich in decaying vegetation, that is swamps, Minerals and rocks that contain iron oxide may undergo reduction from oxides to element iron. For this kind of reduction of oxygen or reduction of reaction, oxygen is getting removed by the carbonaceous content provided by decaying vegetation. Effects of oxidation can be easily observed from the color changes produced in iron-bearing rocks. Now, iron when oxidized to ferric state shows brown color, and ferrous state shows green, blue, and gray shades. The next reaction or chemical process or the next natural chemical process is carbonation that will affect weathering. Now, as I told you earlier, when carbon reacts or carbonic materials or carbonaceous materials react with water vapor, it becomes weak carbonic acid. But you have to understand that though they are weak in nature, the acidity is very weak. The acidic medium is really corrosive in nature and affects a number of silicate bearing rocks. These silicates of potassium, sodium and calcium decay under carbonation. So for example 2KlSi3O8 plus 2H2 plus CO2 will give Al2Si2O5 OH4 plus K2CO3 plus 4SiO3. That is the same thing. I'll repeat. Its orthoclase when reacting with carbonic acid will give kaolinite and silica and potassium carbonate. Now the end products in the reaction that occurs here are clay, minerals and soluble bicarbonate and silica. Now again we have to understand something known as colloid formation. The process of hydration, hydrolysis, oxidation and reduction may not always end in the formation of stable end products. Often they result in the splitting of particles and smaller particles. The colloids characterized by atoms with only partially satisfied electric charges are an example of colloid formation. Formation of colloidal particles is especially common in the weathering of clay minerals, silica and iron oxide. The colloids of these minerals are however soon precipitated as their changes as they are satisfied and they form finally stable products. Now next is spheroidal weathering, and it is a kind of complex weathering which is observed in jointed rocks and characterized with the breaking of original rock minerals. Now these are converted into spheroidal blocks. Now they are both mechanical and chemical in nature, and it is believed that they actively cooperate. Both mechanical and chemical weathering are believed to actively cooperate in causing spheroidal weathering. Now solid rock masses which are split into small blocks by development of parallel joint rocks due to thermal effects is known as insulation. Now you have to understand that in this spheroidal weathering, both mechanical activities are included and chemical activities are included. And as such, in the mechanical aspect, which we saw earlier, we don't have much more points to discuss. And in the case of chemical weathering, they are believed to actively cooperate in spheroidal weathering of rocks. Now, to understand spheroidal weathering, you have to understand that when a solid rock mass gets split into smaller broken molecules by development of parallel joints due to thermal effects is known as insulation. Now, simultaneously, the chemical weathering processes corrode the borders, surfaces of blocks, and other materials. Now, role of plants and organisms in weathering is the first and foremost thing we should understand. Now, plants and organisms contribute towards mechanical disintegration and chemical decomposition. Now, there is another important factor that will influence weathering other than chemical process and mechanical process, that is the role of plants and organisms. Now, certain plants and organisms also contribute towards mechanical disintegration and chemical decomposition of rocks which are present in the crust. Now, the thing is that in some plants or in plants, in the roots, there is presence of hydrogen ions. H plus ions are released at the roots of the plants during their growth and metabolism. Now, these ions are capable of replacing potassium and calcium ions, and also it will replace magnesium ions from the minerals. Now, this is how these minerals are getting absorbed by the roots of the plants. Now, when the plants grow on the crust of the earth on rocks, the H plus ions or hydrogen ions which are released at the roots of the plants will react with the minerals present on the rocks, and as such there is an ion exchange, and the minerals gets into the roots and the H plus gets out of the root. Now, due to this, there is a disintegration and decomposition happening towards the rocks where the roots are there. I mean, the plants with deep roots are there. And as such, we say on rooftops, we should not grow plants with roots which grow deeper. Now, root systems and conifers, for example, for conifers and big trees, creep into pre-existing cracks in the nearby rocks, and this results in the disintegration and the cracking and loosening a part of stone, and it is a kind of weathering. The breaking down of these rock particles into simpler ones or weathering or due to this process is followed by the rolling down of the slope or the down slope. For example, if it happens in a hill, sometimes the fragmentation of rocks will create or will be followed by their rolling down or towards the downside of the slope of the hill. The fragmented rock particles will be carried forward or carried downwards. They roll down to the slope or to the bottom of the hill. Now, all these kinds of disintegrations are happening because of living beings, and this kind of weathering is known as organic weathering. So, the three kinds of weathering are mechanical weathering, chemical weathering, and organic weathering, or weathering due to living organisms or weathering due to plants and animals. So, we have seen incomplete perspective the turf weathering. Thank you.